Most JavaScript videos oversimplify the execution context. Some might even confuse you. We will break down the three components, and we will discuss the working of these components during different phases of an execution context. I will give you a spec-aligned understanding of the execution context with a working example. This video is just the part 2 in this series. In next parts, we will see the working of event loop, promises, async, and much more. Hit subscribe now so you don't miss any of that. Before JavaScript executes your code, it performs 3 major steps. Parse your code, create the needed execution contexts, and finally, it runs your code. As discussed in part 1, execution context is a container inside which your code runs. Every time you load a script or call a function, a new execution context is created. I have already talked about each of the components of an execution context like realm, lexical environment, variable environment, etc. in detail in the first part of this video. I have provided a link to that video on the screen, as well as in the description box. I highly recommend you check out that video first, as it will give you the basic understanding you need about the components of an execution context. Alright, let's begin. The lexical environment is the heart of how JavaScript manages scopes. When JavaScript finds let, const, or function declarations inside a function, those are placed into the lexical environment during the creation phase. That means this happens before your code even runs. Just by reading your code, it knows what variables exist, what functions exist, and where this scope sits inside other scopes. Note that they exist, but their values are not assigned yet. This is why let and const behave differently from var. They are hoisted, but uninitialized, which creates the temporal dead zone. The variable environment works almost the same way as the lexical environment, but it handles var declarations. Var variables are hoisted and initialized immediately to undefined. They do not enter the temporal dead zone. Please note, modern JavaScript engines often treat lexical and variable environments as a unified system internally. But the ECMA script specification explains them separately because they behave differently during creation and initialization. Call stack is a runtime, last in first out stack that tracks which code is currently running. When the program starts, the global execution context is created and pushed onto the call stack. When a function is called, the engine creates a new function execution context for that call and pushes it on top of the stack. When that function returns or finishes, its execution context is popped off the stack and control returns to the one that is now on top. The stack becomes empty when there are no more active execution contexts and the script is finished. We will take this code snippet and the call stack right here to track the flow of execution of this code. As soon as the script loads, an execution context is created to hold the environment record and scope. It will be pushed onto the call stack. During the creation phase, the identifiers a and outer will be known. Since the variable a is declared with var, it will be assigned as undefined immediately. Outer will be fully initialized since it is a function. And the this binding will have the global object. Now, the execution phase begins. In the first line, variable a will be assigned with the value 10. Next line defines outer, which is already there, so no runtime action. In the next step, outer function call is encountered, so it creates the outer's function execution context and pushes it on top of the call stack. Again, same creation phase will be repeated. X exists as a parameter slot, but no value yet, until execution assigns. B exists in lexical record, but is uninitialized. Inner function object is fully available. Now the outer reference in this function execution context will point to the global execution context. The execution begins. X becomes 3. Then, B will be evaluated and become 6. Next line will call inner function. A new function execution context will be created and pushed on top of the call stack. During the creation, it creates a blueprint of all the variables inside it and saves it in the lexical environment as shown. As the execution begins, y is assigned the value of 5. Then moving on to the next line, the evaluation of c begins. Here is the interesting part. How do you think JavaScript resolved the value of b? If you guessed scope chain, then you are absolutely correct. Inner will have a reference to the outer function execution context, and it will find the variable b there. So c becomes 11. Again, for the console statement, it needs a, so it will follow scope chain and get the value from global execution context. After the inner function finishes, its execution context will be popped off from the call stack. The control returns to the outer function execution context, which is now on top. Outer completes, its execution context is also popped off, and same goes for the global one. Let's quickly recap what we just learned. Every JavaScript program starts with a global execution context. Each function call creates the new function execution context, which is pushed onto the call stack. Functions live in the lexical environment, and var lives in the variable environment. The call stack is last in first out, which means it runs top to bottom, pushing and popping as functions execute. Most developers memorize how JavaScript behaves, but not why. You now understand the why. If you want the same clarity for topics like hoisting, closures, and the event loop, subscribe now and drop a comment with the next concept you want me to simplify.